The world's longest high-speed railroad is now running in China. The first train left Beijing this morning, headed for Guangzhou. The new line runs more than 1,400 miles.
China's continued efforts to upgrade, optimize, and specialize their agricultural machinery sector.
Someone told you a skyscraper could rise from the ground in less than 3 weeks? Or that a single machine could carve through mountains faster than nature itself formed them? Sounds like science fiction, right? But here's the twist: it's happening right now, and the world is watching in disbelief. While some countries spend decades planning a single bridge, another nation is building entire cities at speeds that shouldn't be possible. The machines doing this work are so massive, so advanced, that engineers from across the globe are scratching their heads, asking one simple question: how? The answer lies in a country that wasn't even in the game 2 decades ago. Now, it's rewriting the rules of construction, transportation, and engineering itself. Stay with us as we dive into the shocking rise of these colossal machines and the mind-blowing strategy that made it all happen. The impossible takeover. Picture this: the year 2000. The world's tunnel-digging technology was firmly in the hands of Western nations.
In the south of Denmark, a mega project is underway to build a tunnel under the Baltic, linking the country to Germany.
They had spent over a century and a half perfecting these giant underground beasts, and the industry was so specialized that newcomers didn't stand a chance. Fast forward to 2024, and the entire landscape has flipped upside down. The same country that had zero presence in this market now controls nearly everything. 7 out of every 10 tunnel-boring giants operating worldwide come from one place: China. How does a nation go from absolute zero to total dominance in just over 20 years? It's not magic, and it's not luck. It's strategy on a scale most countries can't even imagine. While California spent 16 years and poured billions into a single high-speed rail line that still isn't finished.
A new federal report targeting a high-speed rail project in California identified missed deadlines, budget shortfalls, and other critical flaws.
China built more than 40,000 kilometers of track in the same time frame. We're talking about tunnels, bridges, elevated passages, and stations, all connecting massive cities like pieces in a giant puzzle. What took others a lifetime to build, China completed before lunch. The secret? A national obsession with speed and scale. Instead of letting different companies and universities compete and stumble through trial and error, China aligned everything: government, industries, workers, researchers toward one massive goal. They bought machines from abroad, took them apart piece by piece, studied every bolt and wire, then rebuilt them better and cheaper. It wasn't gradual improvement, it was a full-speed sprint. 150 years of Western progress got compressed into 2 decades of relentless focus. But here's the kicker: machines are nothing without people. And China didn't just build machines, it built an army of engineers. We're talking about 6.7 million students trained with military-level discipline, funneled straight into national projects. Every year, 1.5 million fresh engineers graduate. That's a third of the entire world's supply. The United States? Less than a quarter of that. So when critics wonder how China finishes 10 rail lines while others struggle with 1, the answer is simple.
Largest railway project, which is the China-funded Padma Link rail bridge, opened its doors late last month.
They have the people to do it. And these aren't just numbers on paper. These engineers work differently. In most Western countries, construction halts for weekends, holidays, bad weather, or heat waves. In China, it's a non-stop operation. Crews rotate in 3 shifts, working around the clock, 7 days a week, no matter the conditions. Midnight, there's a crew drilling through rock. Dawn, another team is already replacing them. It's not chaos, it's choreography, drilled into them from the classroom to the worksite. By the end of 2024, China held 3.5 million active invention patents, and more than half were already being used in real projects. In many Western nations, patents sit in filing cabinets collecting dust. In China, They're tools of war, economic war. This scale and discipline change everything. When a Western engineer says a bridge will take 5 years, a Chinese team answers with 1 year and delivers. Roads rise in Chongqing faster than permits get approved in Los Angeles or London. Now imagine this: 1.5 million new engineers entering the workforce every single year. Multiply that by 2 decades. What you're looking at isn't just a workforce, it's a force of nature. And it's all aimed at one thing: building the impossible. The underground revolution. Let's talk about the machines themselves, because these aren't your average construction tools. These are mechanical giants capable of slicing through 10 kilometers of solid earth in a single day, and doing it for just $10 million, a fraction of what similar projects cost in the United States. China's tunnel-boring machines are engineered for extremes, from soft soil beneath crowded cities to deep underwater tunnels and earthquake-prone mountains. They carve through the ground with astonishing speed, safety, and surgical precision. Take the CRCHI machine, for instance. This behemoth is 15 meters wide, one of the largest tunneling machines on the planet. It generates nearly 10,000 kilowatts of power, delivers more than 42,000 newton meters of torque, and digs at a steady 50 millimeters per minute. It completed one of the twin highway tunnels beneath a river in record time, cutting through dense ground as smoothly as a blade through butter. Then there's the Caucasian machine, 15 meters in diameter, 182 meters long, and weighing nearly 4,000 tons. It's one of the largest hard rock borers in existence, capable of moving massive volumes of earth in mere weeks, work that would take others months, while maintaining perfect balance, precision, and safety. The real secret, though, lies in the technology within. Advanced slurry shield systems balance pressure between the cutting chamber and surrounding soil, preventing collapse even beneath bustling cities. Hydraulic jacks and flexible joints help the machine adapt to shifting ground, while the slurry minimizes vibration crucial in seismic zones. Each machine is a digital marvel. Sensors track torque, thrust, and ground pressure, adjusting operations in real time. Geological mapping tools predict soil changes, allowing for continuous speed and stability. Remote operation and automated systems enhance safety and accuracy underground. China's tunnel boring revolution began in the early 2000s when local engineers, many of whom had never even seen such a machine, set out to build their own. In 2008, they succeeded. By 2009, their model completed a metro tunnel in just 4 months with ground movement under 3 millimeters. From that moment, China's rise was unstoppable. By 2023, engineers had created the world's largest main bearing, over 8.5 meters across. Today, China's machines don't just dig, they think, predict, and adapt, redefining what's possible beneath our feet. Building at lightning speed, China hasn't just built the impossible, it's done it in time frames that make the rest of the world look frozen in place. In 2015, a company called Broad Sustainable Building shocked everyone by assembling a 50-story skyscraper in just 19 days. That's 3 floors per day. The secret? Prefabricated modular construction. They manufactured sections of the building off-site, transported them to the location, and snapped them together like oversized Lego blocks. Each of the nearly 3,000 modules was crafted with precision, ensuring they fit together seamlessly. This method didn't just speed things up, it reduced waste, improved quality, and minimized environmental impact. Then came 2020, and the world watched as China built a 1,000-bed hospital in 10 days flat. The Huoshenshan Hospital in Wuhan was initiated on January 23rd and fully operational by February 2nd. To pull this off, over 7,000 workers, engineers, electricians, volunteers worked in rotating shifts around the clock. Cranes, trucks, and machinery moved constantly. Prefabricated units were produced in parallel with site preparation, cutting down time without sacrificing quality. China's supply chains and industrial capacity delivered materials, labor, and equipment without a hitch. Both projects relied on the same principle: precision, speed, and massive coordination. But none of it would be possible without the machines that make the impossible routine. The giants that build the sky. Enter the Iron Monster, a bridge-building machine that's one of the largest land vehicles ever created. Built by Beijing Wow Joint Machinery Company, it measures 91 meters long, 7 meters wide, and 9 meters tall. At 580 tons, it's heavier than some warships. Unlike ordinary cranes that lift small sections and need tons of space, the Iron Monster handles entire bridge spans, weighing up to 950 tons. It lifts a massive concrete beam under its frame, drives it to the edge, locks onto a pillar, extends forward, and lowers the section into place. Then it rolls ahead and repeats span by span until a bridge stretches across the gap. What makes it even more remarkable is its mobility. It runs on 64 wheels grouped into sets of 4, and each group can pivot 90 degrees. This lets the giant slide sideways with precision, positioning beams as smoothly as sliding a plate across a table. Despite its size, it moves steadily 8 kilometers per hour when empty, 5 when loaded. Over its lifetime, one machine can set between 700 and 1,000 spans before retiring. Then there's the Kunlun, named after one of Asia's longest mountain ranges. Developed by China Railway Construction Corporation, it's the world's first transport erect machine capable of handling a 1,000-ton box girder. It does the work of 3 traditional machines while operating on slopes up to 30 degrees and curved tracks with tight radii. It can erect girders of 24, 32, and 40 meters, allowing China to build bridges at unprecedented scale and speed. In June 2020, Kunlun completed its final test and soon erected the first 1,000-ton box girder for a cross-sea bridge. This nearly 15-kilometer bridge was completed in September 2023, far faster than the 4 years it took to build the 3-kilometer Golden Gate Bridge. Kunlun's ability to handle such massive girders reduces train vibration, ensuring stable operation at high speeds and supporting China's push into the 400-kilometer-per-hour era. Kunlun features laser matrix systems for navigation through tunnels, real-time monitoring of girder positions, automated transport and placement, and integration with railway management platforms. Operators track girder conditions live, improving safety and efficiency. These innovations cut construction costs by 20% and boost speed by 25%, all while requiring less space than conventional machines. The power to lift mountains. Now let's talk about raw power. The XCMG XGC 88000 is an ultra-heavy crawler crane that can lift 4,000 tons with a boom stretching 144 meters into the sky. It weighs over 5,300 tons. To put that in perspective, it could hoist a fully loaded Airbus A380 with ease. Entering production in 2013, it became the largest tracked mobile crane in the world, even outsizing NASA's famous crawler transporters. The crane has 2 main sections. The first is the machine itself, with a maximum boom length of 144 meters, an overall length of 173 meters, and a height of 108 meters. 3 massive engines combine for nearly 25,000 horsepower, powering the machine and supporting assembly or backup functions. The operator sits in a spacious cabin the size of a small office, complete with air conditioning and even a sofa for passengers. The second section is the tracked counterweight compartment, nearly 10 meters tall, 29 meters long, and weighing 2,900 tons. Together, the entire crane tips the scales at nearly 5,400 tons.
We've got this amateur footage showing the moment the crane collapsed. Workers suggested the speed was a top priority.
Its boom can be configured in multiple ways, allowing it to adapt to nearly any construction condition while maintaining full load capacity for maximum mobility and efficiency. Since entering service, this crane has lifted modules larger than small buildings, executing moves that would leave conventional cranes struggling. Watching it in action is like watching gravity itself bend a performance decades ahead of what Western engineers achieved with smaller machines. Reaching for the sky. When workers built the Shanghai Tower, they faced a daunting challenge: pumping concrete nearly 2/3 of a kilometer into the sky. Most pumps in the West would fail after a few hundred feet. China's Sany 86-meter pump shattered the world record.
Sany cranes. Today, I'm going to show you our next generation raftering crane, SRC 1100T. SRC 1100T has a maximum lift capacity of 110 metric tons.
Sending wet cement 621 meters high, higher than the Eiffel Tower. It earned the nickname Pump King. As of 2024, it holds the Guinness World Record for the longest truck-mounted concrete boom. The pump's boom has 7 sections, longer and more flexible than conventional designs. This allows operators to reach confined urban sites and complex terrains with ease. Constructed from high-strength steel, the boom maintains stability under immense pressure during extreme high-rise pumping. Mounted on a 9-axle all-terrain chassis, it offers superior mobility and stability. Its automatic boom system enables one-touch deployment, vertical and horizontal pumping, boom locking, and area limiting. Advanced stabilization reduces boom shaking by 50% and cuts swinging range by 60%, ensuring precision and safety. Energy-saving technology boosts operational efficiency by 25% while cutting fuel consumption by 10%. The Pump King has left its mark on high-rise construction worldwide. On projects like the Shanghai Tower, it pumped ultra-high-strength concrete to 620 meters, a world record. Its precision and reach allow China to construct skyscrapers faster, safer, and more efficiently than ever before. Laying the foundation. China's 500 CYP track-laying machine is capable of laying 2 kilometers of track in a single day. It operates 24 hours straight, transforming railway construction into a continuous high-efficiency process. In March 2020, it made its Southeast Asia debut on the China-Laos Railway, installing a 500-meter steel track in Vientiane, the first section of the railway and the longest steel track outside China in Asia. The machine performed flawlessly, surpassing its daily goal of 1.5 kilometers with ease. Designed for high-capacity, large-scale projects, the CYP 500 integrates track laying, alignment, and precise placement into a single automated workflow. Its continuous operation minimizes downtime, while advanced control systems ensure rails are positioned with millimeter-level accuracy. The machine tackles challenging terrain, complex curves, and long bridges or tunnels, keeping pace with even the most demanding schedules. In just 4 years, CYP 500 technology increased China's track-laying capacity from 500 meters to 2 kilometers per day, setting new standards in efficiency. Climbing to new heights. The secret behind China's ability to construct towering skyscrapers in record time lies in the Bosnot, a wall-climbing construction giant engineered to transform high-rise building. Standing over 40 meters tall and weighing nearly 2,000 tons, it dramatically accelerates construction speed, completing a floor in just 4 days, over 20% faster than conventional methods. Unlike traditional cranes, the Bosnot doesn't rely on external scaffolding. Its reinforced steel frame combined with integrated hydraulic and automated systems allows it to lift and assemble prefabricated panels, girders, and beams while maintaining absolute stability. Advanced sensors continuously monitor stress, tilt, and load distribution, preventing structural errors even at extreme heights. One of the machine's most remarkable features is its vertical climbing system. After completing a floor, it elevates itself to the next level without disassembly or repositioning. Hydraulically controlled jacks and counterweights maintain equilibrium during ascent, while automated controls adjust for wind forces, structural shifts, and weight distribution. The Bosnot is equipped with sophisticated automation and precision control systems. Sensors and software measure, align, and adjust structural elements in real time, allowing the machine to perform heavy lifting, precise alignment, and assembly with minimal human input. Its intelligent algorithms can make minor corrections automatically, ensuring smooth operation under variable conditions. Moving the giants. The most surprising thing about these mega machines is that they aren't confined to China. They can be deployed anywhere in the world, thanks to a purpose-built mega vessel designed to transport them safely and efficiently. The Yihong Jinyun 2 is a semi-submersible heavy-lift vessel built to transport oversized project cargo, including 10-megawatt offshore wind turbines and their components.
Project cargo that they wouldn't find in another industry.
Well, I think excitement is the first thing. As you said, benefits acquisition of knowledge, technical knowledge.
Measuring 115 meters in length with a 26-meter beam, it provides a stable platform for heavy cargo operations. Its 2,000 square meter deck can accommodate up to 6,000 tons of material, while reinforced structures allow it to carry vehicles including 60-ton trucks safely. Adjustable pillars, modular deck fittings, and a reinforced springboard system make it capable of handling irregular cargo while distributing weight evenly. The vessel's propulsion and positioning systems combine power and precision. Twin main engines drive fixed-pitch propellers supported by a bow tunnel thruster and a 4-point mooring system, allowing accurate placement even under strong winds. Advanced automation enhances both performance and sustainability. An intelligent energy management system monitors propulsion, onboard machinery, and navigation in real time, optimizing power distribution and fuel consumption. Purpose-built for civil engineering, offshore construction, and heavy cargo transport, the Yihong Jinyun 2 excels at carrying wind turbine components, prefabricated structural sections, and other large-scale project cargo over long distances. Its robust deck, precise positioning systems, and load handling capacity ensure safe transport of up to 6,000 tons per voyage, supporting high-value and oversized cargo, where stability, efficiency, and careful handling are essential. So there you have it, the story of how one nation took engineering from impossible to inevitable. From tunnel-boring machines that reshape mountains, to cranes that lift the weight of warships, from skyscrapers that rise in weeks, to hospitals that appear in days, China has turned construction into a form of national power. These machines aren't just tools, they're symbols of focus, discipline, and relentless ambition. While the rest of the world debates, delays, and deliberates, China builds. And it builds faster, bigger, and more efficiently than anyone thought possible. The machines are impressive, sure, but the real story is the system behind them. The millions of engineers, the synchronized supply chains, the 24-hour work cycles, the national will to turn plans into reality at breakneck speed. That's the formula. That's the secret. And that's what has experts around the world stunned, speechless, and scrambling to catch up. If you found this story as mind-blowing as we did, make sure to hit that like button and subscribe for more incredible deep dives into the world's most astonishing achievements. Trust us, you won't want to miss what's coming next.